Welcome to Blueprint to Reality, the channel where we break down the science and art of civil and structural engineering. Here, we dive deep into what holds the world around us together and what keeps iconic structures standing tall. Today, we're exploring an often overlooked connection in engineering, the role of architecture in structural integrity. So, let's get started. What is structural integrity? Before we jump into how architecture impacts structural integrity, let's get a solid understanding of what we mean by structural integrity. In engineering, it's essentially the strength and stability of a structure under expected loads, weather conditions, and daily use. Structures like buildings, bridges, and dams must be designed to withstand forces like gravity, wind, earthquakes, and even the wear and tear of time. Achieving strong structural integrity means that the structure can resist these forces safely and effectively throughout its lifespan. The architect's vision and structural integrity. Architecture brings more than just beauty to a building. It shapes its very framework. Architects decide the shape, size, and layout of a structure, which significantly impacts how it handles stress and strain. For example, adding open spaces or unusual shapes can increase structural demands and influence material choices. Architects and engineers work together to create a design that looks incredible but also keeps structural integrity at the forefront. For instance, in skyscrapers, a tapering shape can help manage wind loads, while curved forms might distribute weight more evenly. Examples of architecture enhancing structural integrity. Some of the most famous structures in the world are brilliant examples of architecture enhancing structural strength. Think of the Eiffel Tower. Its lattice structure was designed not only for aesthetics but also to reduce weight and resist strong wind forces. Then there's the Sydney Opera House, where the unique shell structure helps distribute loads efficiently while giving it an iconic look. These designs show how creative architectural ideas can directly support the strength and safety of a structure. Balancing aesthetics and safety in modern architecture. In today's world, sustainable and innovative design has become essential. Architects and engineers are now balancing aesthetics with environmental impact and material efficiency. Take the Burj Khalifa in Dubai, the world's tallest building. Its Y-shaped base offers maximum stability, distributing weight evenly, while its tapering design reduces wind loads at higher levels. This perfect balance between beauty and safety demonstrates how modern architecture continues to enhance structural integrity. Conclusion. Architecture and structural engineering aren't isolated disciplines. They're partners in building structures that are both beautiful and resilient. When architects and engineers collaborate effectively, they create spaces that aren't just functional but also enduring. Architectural creativity combined with engineering principles allows us to push the boundaries of design while keeping safety as a top priority. Thanks for joining us on Blueprint to Reality. If you enjoyed this breakdown on the role of architecture in structural integrity, don't forget to like, subscribe, and hit the bell icon to stay updated with more insights on engineering marvels and concepts. Drop a comment below with your thoughts or questions, and we'll see you in the next video. Welcome to Blueprint to Reality. This is the place where we make complex engineering concepts simple and relatable. Today, we're diving into a topic that's as impressive as it is vital to our infrastructure: bridge construction. Bridges connect us across rivers, valleys, and even seas, but how do they actually work? Today, we'll break down the mechanics behind bridge construction. Let's jump in. The basics of bridge mechanics. Let's start with the basics. What exactly does it take for a bridge to stay standing and hold weight? In engineering, a bridge's stability comes down to managing forces like compression and tension. Compression squeezes materials together, while tension stretches them apart. A bridge needs to balance these forces across its structure to safely bear loads like vehicles, trains, and even wind. The type of bridge, whether it's a beam bridge, arch bridge, or suspension bridge, determines how these forces are handled. Key components of a bridge. Now, let's talk about the key components that make up a bridge. First, there's the deck, which is the flat surface we drive or walk on. Beneath that, we have beams or trusses, which provide structural support. The piers or towers hold up the main deck and transfer weight to the foundation, which anchors the bridge into the ground. Finally, we have the abutments at each end, keeping the bridge stable and connected to solid ground. Each component has a role in distributing the forces acting on the bridge, ensuring it remains safe and durable. Types of bridges and their mechanics. There are several types of bridges, each with its own way of handling forces. Beam bridges, for instance, are the simplest. They span short distances and rely on beams to distribute the load evenly across supports. Arch bridges, meanwhile, use a curved structure to transfer loads outward and downward, which helps them handle greater weight. Suspension bridges, like the Golden Gate Bridge, have cables that carry the deck's weight and pass it through towers down to the ground. The type of bridge chosen depends on the location, span, and expected load. Each design maximizes efficiency and safety. Challenges and innovations in modern bridge construction. Today, bridge construction faces new challenges. Engineers are now designing bridges that withstand extreme conditions like earthquakes, high winds, and heavy traffic. Materials have also evolved, with high-strength steel and concrete allowing for longer spans and greater load capacity. Innovations like cable-stayed bridges combine elements of suspension and beam bridges to support longer distances with fewer piers. Smart technology is even being incorporated to monitor structural health in real time, helping detect issues before they become major problems. Conclusion: building a bridge is as much a science as it is an art. Every component, force, and material is carefully calculated to ensure that the bridge is not only functional but also resilient. Bridges are lifelines, connecting people and places, and understanding the mechanics behind their construction reveals just how incredible these structures are. Thank you for watching Blueprint to Reality. If you found this breakdown on bridge mechanics interesting, make sure to like, subscribe, and ring that notification bell to stay up to date with more engineering insights. Let us know in the comments if there's a specific type of bridge or engineering concept you'd like to learn more about. See you in the next video.